So here we go, the Chapter 7 practice test. Remember, you cannot use this actual test as your notes when we take the real test, when you take the full chapter test. However, you can take notes from your practice test on your piece of binder paper that you get to use for your test notes. So be sure that you are taking really good notes now. And remember, if you don't get all the notes down, this video will stay on the website, so you will still have access to it. All right, so let's jump in here. Problem number 1, let's scroll this a little bit. Problem number 1, they want you to identify this angle. Well, this angle is greater than 90 degrees. And since it's greater than 90 degrees, it is an obtuse angle. The other angles shown, an acute angle would be less than 90 degrees. A right angle would be equal to 90 degrees, and a straight angle would be equal to 180 degrees. But this angle, the one that we're looking at, is the obtuse angle because it is greater than 90 degrees. Number 2, what is the value of x? Well, here's what we know. This whole piece right here, all of this together represents a straight angle, which means it represents an angle of 180 degrees. So that 180 degree angle has two parts to it. It has the 8x part and it has the 140 degree part, and all together those equal 180 degrees. So we're going to go through, we're going to take away the 140. Remember, since we're dealing with all whole numbers, we can go ahead and show it as subtraction. And that's going to cancel out. So all of this cancels. And what that leaves us is 8x on this side and 40 on this side. We go ahead, we divide by the 8, divide by the coefficient, so we can see what 1x is, and in this case, 1x is 5, and our correct answer is D. Number 3, what's the value of x in this problem? Well, this right there tells us that the total angle is 90 degrees on this one. So since the total angle is 90 degrees, we know that 90 degrees is made up of the 2x and the 42 all together. That is 90 degrees. We're going to take away the 42, that's the constant. Whenever we solve one of these, we remove the constant first. And that leaves us with 2x equals 90 minus 42. Got to borrow from that, make that a 10. 10 minus 2 is 8. 8 minus 4 is 4. We now divide by 2. And we get x is equal to 24. And you could double check and see if that's true by going back to the problem and saying, all right, if I take 2 times 24, what do I get? I get 48. If I had 48 and 42, I now have a total of the 90 that I'm supposed to have. All right, so on to problem number 4. Angle 1 and angle 2 are supplementary. So whenever you see something like this, they toss out a word at you, go ahead and look at that right away and ask yourself, what does that mean? And remember, that means supplementary Supplementary is two angles total 90 degrees. All right, so we know, oh, excuse me, I was busy writing and talking and not thinking. Excuse me, total 180 degrees. So two angles that total 180. So we know then that if you take 63 and you add angle 2, you're going to get 180 degrees. So take away the 63 from here and take away the 63 from here, and we know that angle 2 is equal to, got to borrow from that, 10 minus 3 is 7, 7 minus 6 is 1, bring down that 1. We know that angle 2 is 117 degrees. A building is 360 meters tall. A scale model of the building uses a scale of 1 centimeter to 6 meters. How tall is the model? So we know the actual building is 360. We know this is our scale. 1 centimeter, 1 cm is equal to 6 meters. The actual is 360 meters. We want to know how many centimeters tall the model is. Well, we can solve this by saying to ourselves, all right, 6 times what makes 360? Well, 6 times 6 makes 36. So 6 times 60 is 360. So what's 1 times 60? It's going to be 60 centimeters. Our answer on this one is B. Okay, problem number 6. Here we are. On a map, the scale is 1 inch to 125 miles. What is the actual distance? So it's always important that you know what it is they're asking for. So this is what we know. We know that our scale is 1 inch equals 125 miles. The distance on the map is 4 inches. How many actual miles are there? Actual distance. Well, 1 times 4 is 4. So what's 125 times 4? That's what we're going to do here. Is we're going to multiply 125 times 4. And 125 times 4 is 500. Our answer is C. Another way of thinking about that problem is what we're doing is we're multiplying 1 times the x, and we're multiplying 125 times the 4, and we get x is 500. So either way you look at it, our answer is C right there. X is 125, or the actual distance is 125 miles. On to the next page. In the figure at right, what is angle 2 if angle 4 is 120? Well, if angle 4 is 120 degrees, then angle 2 is 120 degrees, because angle 2 and angle 4 are, what are they? You got it. They are vertical angles. Vertical angles. And vertical angles are congruent. They have the very same measure as each other. Number 7. What's the classification of the triangle by its angles and its sides? Well, we know that all of these angles are less than 60 degrees. Less than 60 degrees, which makes it acute. There's a possible. There's a possible. It is definitely not a right. It is definitely not an obtuse. So is it equilateral or is it isosceles? Well, since we only have two sides that are the same, we know that it is isosceles, and our answer is B. That's an acute isosceles triangle. What a cute little triangle. On to problem number 8. So what is the value of x in the triangle? Well, here's what we know. We know that if you add all the angles of a triangle together, you get 180. So 25 and another 25, so we know that 50 plus x is 180. If we take away the 50, we get x is equal to 130. So x is 130 degrees, which makes it what kind of angle? That's correct. It makes it an obtuse angle. Number 9. Okay, the fun of drawing. Number 9. Draw the top, the side, and the front view. Well, the top view looks like this. That's what you would see looking down from the top. Yours is also correct if it's turned the other way around, if the opening is at the top. That's fine. What's the front view look like? Oh, the side view. Side comes next. Well, the side view would be a rectangle. What's the front view look like? Well, the front view looks like a rectangle. Whoops. The front view looks like a rectangle. And that rectangle is going to have these two parts in it. So this is that. And then this recessed back is this. But when you look at it across the front, it just looks like a rectangle that's been divided into 3 parts. Number 10. Which solid, A or C, which solid has a top, side, and front view that looks like this? Well, actually none of these does. I wonder what happened here. It looks like maybe... Oh, actually C does. I'm sorry. My brain took a vacation for a minute. So on C, you've got this top view. Oh, pen craziness again. On C, you've got this top view right across here. And then looking at it from the side, you're going to see this like so, and looking at it from the front. So our answer is C. Thanks for ignoring the pen craziness. Number 11. What figure is shown? Well, you know it's not a pyramid because it doesn't go up to a pointy top. So the pyramids are out. It's not B, not C. Is it a rectangular prism or a triangular prism? Well, since the base is a triangle, since when you look at the bottom of it, since the base is a triangle, it is a triangular prism, and our answer is A. Lastly, looking at that figure now, can you name some stuff here? Name a base, a face that isn't a base, 2 edges and 2 vertices. Well, the base is the one that I did right there, ABC. ABC. Name a face that isn't a base. Oh, by the way, you could have answered also DEF. Either one of those would be right. How about a face that isn't a base? Well, that's going to be one of the rectangles. So for faces that aren't the bases, let's just put that right here, because I want more room than's right there. I could have ACFD. I could have BCFE, or the very back of it, ADEB. Any one of those would have been acceptable. If I want two edges, and again, I've got a lot of choice, pardon me, when it comes to edges. So let's just put edges right over here because they're going to be a number to pick from. So you need to have two of these that I list. So AB, AC, or AD, or, and I'm going to make a whole list here, and you just have to pick two out of this list. BC is an edge, and BA, but we already listed that one, and BE. You can see I'm kind of I'm trying to be strategic about this. C, now I already did CA, I already did CB, so we've got CF. Then D, we already did DA, so we have either DE or DF. When I start with E, I've already had E to B, I've already had E to D, so I've got E to F. And I think F I've connected to everything. I connected it to D, to C, D to C, and to E. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And you have to have two out of those 9. Now, how would you know it's 9? Well, here's the way you would know it's going to be 9. Every triangular prism, by the way, has 9. Because the base is a triangle, so there are 3 edges on the base, A to B, A to C, and B to C. There are 3 edges on this base, D to F, D to E, and E to F. And then there are 3 edges connecting them. All right, finally, you need 2 vertices. And the vertices are these single letter points. So you've got A, B, C, D, E, and F, and you would need 2 of those. So pick your answers out of that. Hopefully you got those right. Go back now. Look at the problems that you had difficulty with. Be proud of the ones that you got right. That's great. But look at the ones you had difficulty with. Those are the ones you need to do some extra study before you take the test. And those are the ones that you should study and then put into your notes, because those are the ones you need to concentrate on the most. Okay, great. Be sure you ask questions if there are still things that don't make sense, and thanks for watching the video.